Where everyone demands your trust, we prefer to give you ours. Aryabhatta Learning Forum Pvt.Ltd.
Hello students, today we will be discussing about SN1 mechanism, SN1 reaction. Actually, this is the SN1 is the mechanism of nucleophilic substitution reaction, and this is the nucleophilic substitution. Alkyl halide reacts with nucleophile. It can give nucleophilic substituted product and X minus. And here it is a substitution reaction. Substitution is here alkyl group and halogen atom is there, and this halogen atom is replaced by nucleophile. Then it is a substituted product. This is the nucleophilic substitution reaction. Okay. And in this nucleophilic substitution reaction, you have two mechanisms, and one of the mechanisms is SN1 mechanism. And this SN1 mechanism, what is SN1 mechanism? First of all, the abbreviation of SN1 mechanism is unimolecular nucleophilic substitution reaction. Substitution reaction. This is the abbreviation. SN1 means unimolecular. 1 represents unimolecular. That means the reaction have the molecularity is 1. And nucleophily and nucleophily and S is substitution reaction. And this is a SN1 abbreviation. And this mechanism has two-step mechanism. First of all, write a two-step mechanism. First of all, Rx step 1. Step 1. Rx plus ionized into R plus and X minus. Plus Rx is ionized into R plus and X minus. Here R plus known as intermediate. Intermediate. Next, step 2. Step 2, R plus combines with nucleophile. Okay. And then it can forms R and U and substituted product. Okay. Here the Rx initially ionized it to R plus and X minus. R plus is known as intermediate, and that intermediate again combines with nucleophile and forms a substituted product. And here, first of all, nucleosl1 mechanism is a two-step mechanism, and in between the two-step mechanisms, this is the slow and this is the fast. Okay, and this is the final mechanism of SN1. Okay, based on this mechanism, we can write some important points about the SN1 mechanism, and these points are also very important in Neet and day examinations for subjective and concept-oriented questions. What are the important points? First of all, the first point is it is two-step process. It is two-step process. And the second one is it forms an intermediate. It forms an intermediate. Okay. And third one is very important one. Here the intermediate is formed as a carbocation. Intermediate is carbocation. Again, the intermediate carbocation is formed. Not only in this reaction, in organisms to maximum a carbocation forms as an intermediate. It must be more a rearrangement. Rearrangement is possible. Rearrangement is possible. Okay. Rearrangement is possible. That means if chance is there, then possible. Okay. Based on possibility, the rearrangement is takes based on possibility. Okay. Next. Fourth one. Here the two-step mechanism is there. One is slow, another one is fast. According of chemical kinetics, the rate law is applicable on slow step. Why? Because the slow step is called a rate determining step. This is the rate determining step, and rate law is applicable on this step only. According to rate law, rate is directly proportional to concentration of alkyl halide. Why? Because the total two steps are there. It between two steps, this is the slow step, and these slow steps, they influence the rate. That's why the final we can write rate is directly proportional to concentration of alkyl halide of the. In that case, order equal to 1, our 1 is that order equal to 1, and that molecularity is also 1. Molecularity is also 1. This is the SN1 mechanism. That's why we can know the molecularity, unimolecular. This is the unimolecular nucleophilic substitution reaction. This is the molecularity 1. Okay. And based on this information, we can write the rate of reaction. Rate of reaction per tertiary alkyl halide, secondary alkyl halide, primary alkyl halide. In case of tertiary alkyl halide, secondary alkyl halide, primary alkyl halide, and the rate of reaction becomes like this. Tertiary is more reactive than secondary. Secondary is more reactive than primary. This is also based on this point only. What is the point? Rate of reaction. Rate of reaction is directly proportional to stability of intermediate. Stability of intermediate. What is intermediate? Carbocation is an intermediate. Okay. According to in GOC topic, we can already discuss the stability of carbocation. Tertiary greater than secondary greater than primary. Carbocation stability. C plus tertiary carbocation, secondary, primary. The stability order. Stability order. Carbocation stability order, tertiary greater than, secondary greater than, primary. Along this information, tertiary orbital halide is more reactive than secondary than primary. Okay, this is one. And another one important point is rate of reactivity of alkyl halide. RF, RCl, RBr, RI. I mean alkyl chloride, alkyl chloride, alkyl bromide, alkyl iodide. Okay. In that case, which one have the highest rate of reaction? In that case, in terms of R bond depth, you can write simply in depth. Here the size of R will be same in all cases. Here the size of fluorine, bromine, iodide is different, and the size means flowing. If the size of chlorine is increases, then bond length increases, and again bromine size increases, and again size bond length increases, and then iodine again bond length is increases. If higher port length, weak bond energy, then it can easily cleave, and this bond will be break easy because of easiest formation of R plus, and that reactivity becomes like this. RF less than RCl, less than RBr, less than RI. Okay, this is the most important points of SN1 mechanism. Based on this, I am giving some example. One of the example, then compare rate of reactivity. Okay, rate of reactivity of CH2Cl and CH3CH2Cl. Then compare the rate of reactivity of these two SN1 mechanism. In both the cases, which one have more reactive towards SN1 reaction? Which one is more reactive? Which one is more reactive peaks? Then we can follow the same point. Rate of reactivity is directly proportional to stability of intermediate. Here the stability of intermediate means after removal of halogen. Then here we can remove the halogen, and this is the formation of plus. After removal of this halogen, and here the formation of plus. Here this is the carbocation, this is the carbocation. I mean, according to GOC, here there is no resonance. There is no resonance. Okay, here resonance is there. Okay, here resonance there. According to GOC, which is more stable, here no resonance, here resonance. Resonance exists, and more stability, when more rate of reactivity towards SN1 mechanism. Okay, this is a comparison, how we can compare the rate of reactivity. Okay, and this is the first important part of SN1 mechanism. Okay, next. mention second good part of SN1 mechanism is stereochemistry. Stereochemistry of SN1. This is also very important one. Here maximum questions are comes from this part of SN1 mechanism, stereochemistry. What is the stereochemistry? Stereochemistry is observed if the alkali halide is a chiral. Here also I am writing one of the chiral molecule. Chiral molecule means here pH, here CH3, here H, here hex, halose, any one of the chlorine, bromine, iodine, any one of the. Okay, this is the chiral carbon. If the chiralities exists, we can easily observe the stereochemistry. Okay, here the chiral carbon. In that case, nucleophilic substitution. First of all, I'm writing step 1. Step 1. In step 1, what happens? C bond pH, bond CH3, bond H. Plus X minus, ionization. Here is the very important in stereochemistry. This is the very important. Actually, in that case, the hybridization of carbon is sp3. But here the hybridization of C plus is sp2. That means, in that case, sp2 hybridization. sp2 means trigonal planar. Trigonal planar means here pH, here CH3, here H. Typhus. Okay. And another C plus now. C plus means one vacant orbital. And this is a vacant orbital. Here the trigonal planar. And the next step, here the next step, step 2. In that case of step 2, nucleophile attacks. In that case, the attacking of nucleophile, there is a chance to both directions. Why? Because here the trigonal planar, the bond angle in between the 120 degree, I mean maximum space is there. The nucleophile is attacks on both directions. There is a chance of both directions. If the nucleophile is attacks in the same direction, the given compound is retention. Retention. Here the nucleophile, here the CH3, and here the H, here the pH. This is the retention. If the nucleophile is attacks on backside direction means here the nucleophile, and here the CH3, here the H, here the pH. And this is the retention configuration. Retention configuration, and this is the inversion configuration. Retention configuration and inversion configuration. Actually, both are not equally 50-50%, and this is the 49% somewhat excess. Somewhat excess of inversion compound is forms. This is a 51% and this is the 49%. Finally, the stereochemistry of SL1 mechanism is racemic mixture. Racemic mixture. What is a racemic mixture? The 50-50%, I mean equal ratio of retention, inversion, combination, a mixture is called a racemic mixture. Okay. Here the stereochemistry of SN1 mechanism is racemic mixture. Okay now, and this is the SN1 mechanism, and is one of the important point rearrangement. For that, I am giving one of the example for this. For this reaction, if you do the SN1 mechanism on this reaction, what product is observed? In that case of SN1 mechanism, here the nucleophile, I am writing nucleophile for rearrangement, for understanding of all points I am writing in the on the board. Okay, and here the nucleophile, what product is observed? Here I am writing first step, ionization, the bromine is breakdown and the product is like this. Okay, but here the carbocation is primary carbocation. If arrangement is possible, that means here possibility is there. If here the adjacent carbon is having 3 methyl groups, if one methyl group is shifted to this carbocation, okay, what about here the two carbons are two methyl groups are there, and here C plus, and this C plus is connected to this methyl, and this methyl group is shifted to this compound. Okay, and the positive charge, I mean this carbon can lose the methyl group, then this is the positive charge. Okay, this is the rearrangement. If the possibility means already formed positive charge, and the rearrangement is takes place after rearrangement we can getting the most stable carbocation. If you get the most stable carbocation, the rearrangement is possible. That is the possibility of rearrange. And then the nucleophile attacks on this position. Nucleophile is attacked, and the product is this is the okay. This is the final answer of this reaction. Are you clear? Okay, this is the important topic about the SN1 reaction. I hope you understand